All right. Good evening, everybody. So, all right. Good evening, everybody. So, let's continue. I got a notification. Commented. Right. Well, we are supposed to do this at 2. We got something, so we went out. So, where are we now? Yeah, we are here. We are at question number 48. So, the logical address is 2 power 32 bytes. Two-level hierarchical paging. So we don't know about two-level hierarchical paging. Let's see the answer. Okay, 32 bits address. We have written that. And page size is 2 power 12. So page takes 12. Inner page length. Let's do paging. Okay, there are 2 power 20 pages. Alright. Page size is given. So you can get the number of pages. Page table 1 size. Inner page. Number of page table entry. So can you explain this story for me, please? Okay, 32-bit address. Okay. 12 bits are used for page offset. Inner page table. Don't we have a tag? Yeah, that is our first question. Each page table must be into one page. 9 bits are needed. Okay, see. In the cache, memory address is split into tag, index, and block. But what are we talking here? Okay, we do not have tag. This all happened because we didn't have command on the subject. Outer page table, inner page table, and offset. Offset is to pinpoint the location. So all of this is 32-bit, and page size is 4096. That is 2 power 12. Okay. So 2 power 20. 12 bits for offset. Does that make sense? Yes. To pinpoint inner page table entry size. Each entry in the inner page table uses 8 bytes. Inner page entry size is equals to 2 power 3 bytes. Okay, that makes sense. Each page table must fit in one page. So, this is page size, number of entries in inner is 2 power 12 minus 3, that's 2 power 9 entries, that is 512 entries, because 2 power 10 is 1024. 9 bits are needed. 9 bits for inner page index. Everything adds up to 32. Outer plus 9 plus what is offset length? Offset is 12 is equals to 32. So 20 minus 9, outer is 11. That's it. It is as simple as that. It is simple if you know the concept. If you don't know the concept, then you cannot do anything. At VB vertex in graph, BFS in G starting at vertex V. At any vertex, you run BFS. That you be a vertex in G at maximum distance from V given by the BFS. By the BFS, it should be in the maximum distance. Run BFS on G again with U as the starting vertex. Let G be the vertex at maximum distance from U. Output distance between U and Z in G. Okay. So we have a graph, right? We have a graph. Let this be V, and then U will be the maximum length. Run VFS on J again with U as the starting vertex. If you run Z be the vertex at maximum distance from U. Yeah. This is the graph I see. Let's do this. What is the farthest from this vertex? Wow, bro. From this vertex, not U be the vertex at maximum distance from V. If I took this as V, right? 1, 2, 3. 1, 1, 1, 2. 1, 2, 3. 1, 2, 3. Maximum distance that this VU, and the maximum distance is 1, 2, 3, 4, 5, 6. Do we have anything greater than 6? 1, 2, 3, 4, 5, 6. I think it is 6, dude. Oh my. Dude, I made it. Okay. This is not going anywhere. Okay, I broke gate syllabus. I will send the PDF Pro or let's see. This should work out. Right, I solved a question. Congratulations to me. Okay. How about this one? 1, 2, 3, 4. Product with the product of symbols in X modulo 7. Product theory of computation. Okay, we take product of epsilon is 1. Where, for example, product of 124. Okay, that example is very much needed. Symbols in X modulo 7. Define L. The number of states in the minimum state DFAFL is. Okay. He's asking for the number of states in DFA. 1, 2, 3, 4. Okay. Product of X is equals to 2. We need to compare it for 2. Okay. So what are all the possible combinations? 1 into 2, it gives 2. 2 is there, 3 is there, 4 is there. Right. 6 is there, 8 is there. 1 is there. 1, 2, 3, 4, 6, 8. 2 4s are 8. Alright. 1, 2, 2, 3, 2, 3 are 6. 2 4s are 8. 3 4s are 12 is there. And 1, 2, 3 again 6. 1, 2, 4 again 8. 2, 3, 4. What is 6, 3, 7, 24. Alright. I think these are all the possible numbers that we can get out of it. So what are the states? So this is 1, 2, 3, 4, and 6. 8 mod 7. 8 mod 7 is 1 again, and 12 mod 7, that is 5, and 24 mod 7 is 1 again. So 1, 2, 3, 4, 5, and 6. Oh god, you have all numbers. So you need 6 states. 6 states. Ah, dude, what is the answer? 6. Yo, you made it. Yeah, you cannot get. You do not have 0. Now I'm feeling happy. Now I'm feeling happy. Okay, for using common sense. An application executes 6.4 into 10 power 8 number of instructions in 6.3 seconds. There are 4 types of instructions. Okay, the details are given in the table. The duration of clock's time in nanoseconds is the duration of a clock cycle. From the previous knowledge, what I have understood is a clock cycle is required per instruction. It needs a maximum number of time, right? It needs maximum number of time. Number of instructions executed. There are 4 types. So we need time. A branch, the instruction type branch, it executes these many instructions and it needs 2 clock cycles. So on an average in one clock cycle it executes 1.125 into 10 power 8 instructions. Okay, I need to check this out. Number of clock cycles is number of instructions executed times the CPI. Clock cycles required per instruction. That's a direct formula. Total number of clock cycles, total execution time, total number. Okay. So we had 2 formulas. Number of instructions executed. What we need? Number of clock cycles. Number of instructions times CPI. Clock cycles required per instruction. The formula. Number of instructions is total instructions executed by the program. Cycles per instruction, average number of clock cycle each instruction takes. Total clock cycle. A clock cycle is the smallest unit of time in a CPU determined by its clock frequency. 2 GHz CPU has it. Okay. I take one cycle of memory. Here's the average cycles per instruction. If each task takes 5 minutes on average, we have 10 tasks. It needs 2 clock cycles and okay, 2 million such branch is the type of instruction that takes 2 cycles and the entire program 2.25 times 10 power 8 of such branches are executed. Perfect. Okay, now that makes sense. Okay, total number of cycles it takes is 2.25 times 2. How much is that? 404.50 into 10 power 8 plus 6.0 into 10 power 8 plus right 16 4s are 64 plus 20 6.6 into 10 power 8 if I'm not wrong. Yeah, 64 plus 6.4 plus 0.2 3.9 into 10 power 8. These are the total number of executions since the powers are same and the basis. This is 10.5, 10.5 plus 6.6, 16, 17.1, 17.1, 20, 21 into 10 power 8. Total number of executions. Yeah, the math is checking out. So per second. No, what is this? Total clock cycles needed per second. It gives how much? Uh, two. Okay, these are okay. These are the total number of instructions, and this is the number of clocks that takes 6.3 seconds are taken needed to execute 21 into 10 power 8 number of instructions. That makes sense. 6.3 by 21 into 10 power 8. Gate calculator. 6.3 by 21. Yeah. 6.3 by 0.3 into 10 power minus 8 is clock speed. Or you can just This is 3 into 10 power minus 1, right? 3 into 10 power minus 9 or 3 nanoseconds. That is 3 nanoseconds. We got the answer. Did we not? Yeah, we got it. It is a C programming pointer manipulation question. We should be able to do this. This is an array of 5. Okay. Pointer is so 30, 50, and 10. Pointer is pointing to 50. Yeah, alright. The value of pointer. Now A is with 50. So, you are incrementing the value of pointer. You are incrementing the value of pointer. Pointer is now pointing to 10. Okay, you need to know the difference between these two. Okay. Okay, pointer is storing the value, right? So pointer gives 11. Pointer value is incremented to 11. A 50 plus 10 plus. I don't know if it's 110 or not. 111. I see. In the pre-process stage, 9 produced with the function declaration and global available by line 3. Okay. By line 4, a new integer array named array. 30, 50, 10, 0, 0. Okay. Available memory. Okay. A new integer provides variable named integer pointer variable. Okay. Okay. Array of 1. Okay. Value of variable. Okay, you are not updating the pointer, you are updating the value pointing to the pointer. Okay, pointer plus plus is updating pointer and ptr is updating value inside pointer. Ptr, so at this step here it will become 51. Pointer is now pointing to 10. So here is 50 and what is pointer pointing to? Pointer is pointing to 10. Array of 1 is now 51. That's 111. That's a 2 marks question. Okay, there is no hashtag easy for this one, thank God. 53. I have read that, I swear to God. A dereferences, right? It is a dereferencing operator. It dereferences the value pointer. It is 50, incrementing 50. Now pointer incrementing. There are two different things. Alright, I guess we are into recursion now. One pointer question, one recursion question. It became the notation. So G is returning and incrementing the value of 10. F is returning, calling G. For n is equal to 1, n is less than 3. That will be 1, 2, n plus plus. Sum is equals to plus or is equals to j of f of n. क्या कर रहा है मेरे से innermost से आता है ना. So f of n, what does f of n call? So first it calls f of 1 and it calls g of n times 2. It calls g of 2. Alright, g of 2 is now what? 2 plus 10. It is g of. Alright. G of 2 returns what? G of 2 returns 12, man. Now it is calling g of 12 again. And g of 12 is what? 22. So sum अभी बन गया 22. 22 plus or is equals to g of f of 2 है ना? हाँ 2. So it calls g of 2 times 2 is 4. It returns g of 4. And what is g of 4 now? 4 plus 10, that is 14. G of 4 returns 14 and G of 14 returns 24. 22 plus 24, that's 46. I don't know if it is anything else other than 46. Yeah, happy. Happy, man. Goddamn happy with that. See, once you master something, things ऐसा ही बनता है. It is not responding very good. A quadratic polynomial probability or complex numbers is said to be a square of invariant. Suppose from the set of all square invariant quadratic polynomials. I don't know. That is a quadratic polynomial or complex numbers, I say. Square invariant. I do not have the necessary theory to solve this question. Help me out, please. 54. Oh shit. Oh shit. Alright. We are looking at it says we need probability that the roots are equal and choosing uniformly from all square invariant quadratics. No, I don't need answer, I need theory. Quadratic polynomial and roots, okay. A quadratic polynomial can be written as that. I know that. x minus alpha, x minus beta. Let's distribute it as x square minus beta x minus alpha x plus alpha beta. If you take minus x common, alpha plus beta plus alpha beta. This is 10th class math. Square invariant. The problem defines quadratic as a square invariant if replace each root by its square and it does not change the polynomial. So this implies both alpha square, beta square are roots. They are the same. And two polynomials are equal, their coefficients match up. Their coefficients must match. Okay. So if you expand this one, right, what will you get? You will get x square minus x beta square minus x alpha square plus alpha square beta square. So x square minus x alpha square plus beta square plus alpha square beta square. So alpha plus beta is equals to alpha square plus beta square. Alpha beta is equal to alpha square beta square. Those are the constraints. Square invariant quadratics. If you say this, what will you do with this? Okay, alpha beta. Oh, I say you are going to take alpha beta as common. Alpha beta. So alpha beta minus alpha beta into alpha beta is equals to 0. Beta is common 1 minus alpha beta is equals to 0. Okay. So alpha beta is equals to 0 or alpha beta is equals to 1. Got it? Equation 1 relates the sum of roots to the sum of the squares. Okay, this made me on the theory. Okay, alpha beta is equal to 0. Alpha. A square invariant topic. Hmm. Can't you delete a comment? That checks out. Yeah. Alpha beta is equals to 1. We need to solve this one out. Okay, 1, 2, 3. Roots are equal, I see. 0. So we got this equal, not equal, equal case 1, equal case 2. Out of how many? 0, 0, 0, 1, 1, 1. Okay. Regarding this question, we have 0, 0, 0, 1. Square invariant quadratic complex conjugates. Quadratic polynomial over complex numbers is said to be square invariant. Quadratic polynomial is said to be invariant. Suppose from the set of, okay. From the polynomials we are choosing one at random. From the polynomials we are choosing one. We are choosing from polynomials, not roots. That is a common misconception. Wow. Wow. That is good. Yeah. So what to do now? We are supposed to solve with I read until here. Alpha plus beta, alpha square plus beta square. Alpha plus beta whole square minus 2 alpha beta. We have already taken the condition as alpha beta is equals to 0. So alpha plus beta is equals to alpha plus beta whole square. We got that. Only 0 squared is equal to 0, 1 squared is equal to 1. So alpha plus beta is equal to 0 or 1. Now compare these two. So alpha is equal to 0, beta is equal to 0, it's only 1. Alpha is equals to 0 or alpha is equals to 1, beta is equals to 0. So in both the cases that polynomial is going to be x square minus sum of roots x plus product of roots. This is going to be 1. And x square 2 square invariants. Spend time on places wherever it is necessary. That is what I have understood. So in the second case, when alpha beta is equals to 1, alpha plus beta is equals to alpha plus beta whole square minus 2 alpha beta. Alpha plus beta whole square minus 2. You're supposed to simplify that one. Yeah. That s is equals to 2 quadratic but substitution. If you do a lot of quadratic problems, you are going to understand it. S square minus s minus 2 is equals to 0. Minus b plus or minus root b square minus 4ac by 2a. What is minus b? That is 1 plus or minus b squared is 1 minus 4 times a times c is minus 2 by 2. That is 1 plus or minus 1 plus 8. 1 plus or minus 3 by 2. That's it. What? B squared is 1 minus 4. Dude, you idiot. 4. Here is 1. 4. This is 8. 1 plus 8, 9. Oh yeah, that is correct only. S is equals to 4 or minus 1. Why are you even solving this? So you get alpha plus beta. Okay, you don't know the value of alpha plus beta. Alpha plus beta is 4 or minus 1. And alpha beta is equal to 1. This constraint should be solved as well. Let's substitute in the original polynomial x square minus sum of roots. What is sum of roots? Alpha plus beta into x plus product of roots alpha beta. This is our one. So we will get x square minus 4x plus 1. Am I doing it right? I don't know. X square plus x plus 1 is equal to 0. If you do this, what will you get? Minus b. 4 plus or minus 16 minus 4 into 1 into 1 by 2. That is 4 plus or minus 16 minus 4 is root 12 by 2. Alright. You idiot. S is equals to 2, not 4. So this is 2 and this is b square is 4. 4 is 4 minus 4. You can even substitute it here, right? I mean, you can. One minus 2 plus 1. Yeah, that works out. This is 1 minus 2 minus b. This is 2 again. 2 by 2. So that is 1. 1 comma 1 are the roots. So x minus 1 whole square is a factor. If you do it here, minus 1 plus or minus root b square. What is b squared? 1 minus 4 by 2 minus 1 plus or minus root 3I by 2. Oh wow, you solved it. So not same. Don't bother about it. 1 1. This is same. X square. How many possibilities? It will give one polynomial, and this one the yeah. This one, that is 2 by 4, that is 0.5. Okay, you did something. That is some math. That is some math. The unit interval 0, 1 is divided at a point chosen uniformly over the distribution into two disjoint subintervals. The expected length of the subinterval that contains 0.4 is. This is again probability. We do not have idea about probability. Uniform distribution. It is asking 2-mark question. Okay. Yo, we did this. We did some integrations. You cracked the code. Alright. It is 59 minutes already, and I think I will take a break. Okay. Yeah, we did something. Where are we now? We are here. Okay, it is something related to properties. I don't think we have matrix multiplication in this, do we? No, we don't. Okay, I find the eigenvalues. I see. Calculus, I see. I don't know. the value of x such that x greater than 1 satisfying the equation. One to x dln t dt is equals to 1 by 4. We don't know the integration. Should I apply the chain rule here? Integration of u. No, I don't know. Yeah, by parts, you call it by parts, I see. We'll check it out. Binary tree in which every node has either 0 or 2 children. Got it. The number of nodes in T. Which one of the following number of nodes in T? Exactly 2 children. And minus 2 by 2. What number of nodes? No idea. So the tree is implying to be a complete binary tree. So we have 1, 3, 7, 15, right? Which is implying all of these. 2 minus 2 by 2, that's 0. 3 minus 2, 4 minus. Which one of the following? Yeah, full binary tree, I have understood that. Number of nodes that are having exactly 2 children. Number of internal nodes it is asking. We messed up with the question itself in the first place. So the number of internal node is 1. The number of internal node is 3. Number of internal node is 7. Which is following the series 2 minus 2 by 2, that's 0. 3 minus 4 minus 2 by 2. Okay, wait. From this, you are supposed to get that if you want that. It is absolute ln minus 1 by 2. You did not understand the question properly in the first place. Non-singular matrices equals to L inverse. Something like that. L power minus 4 m is equals to yeah. Arbitrary predicate over a domain of natural numbers p of 0 and for all x p of x implies p of x plus 1 implies for all x p of x. Okay, on the domain of natural numbers. It seems like mathematical induction. Predicate holds for 0. If predicate holds for x, then predicate holds for the next one. So it holds for everything. That's mathematical induction. Predicate holds for 0 and I don't care about that. I don't care about that. A should be the answer. Beautiful. Really, indeed, beautiful. Right, I'll take a bath and then I'll come back. So, see you, people.